Okay, so I'm going to take a step back today in the supply chain side of things and really look at the graphite end of things. So I'll go into just a breakdown of the presentation. So an introduction into who Arq are, what our product is, and the process of actually turning waste product into high quality carbon, and some of the range of opportunities that we have in the past explored, as well as our current areas of interest, and some of the backdrop into the graphitic needs and the graphite market itself, and some early proof points with the next steps as well. So we are a mid-sized company, I'd say about $100 million turnover per year, specializing in the production and manufacturing of activated carbon for wastewater, ground remediation, as well as air gas treatment as well. This is our primary business. We are also, in recent collaborations and partnerships, we've bought a smaller company that produce bituminous coal as well. So we utilizing this feedstock for several different avenues, which I'll talk about. We're one of the top 3 municipal activated carbon suppliers in the US. And these are our sites on the right. So the top right-hand picture is our Corbin, Kentucky site that produces bituminous coal from waste coal, which I'll mention in a minute. And the bottom right picture is our activated carbon plant in Coshota in Louisiana. So we are very fully vertically integrated organization. So our raw materials are mined. So we've got a mine site near the Louisiana site, as well as waste coal feeds from our Kentucky plant as well, followed by obviously internal processing and the customers as well in the US. So very US centric for now, and all the technology supply chain customers as well. So for the purpose of the talk today, the Corbin, Kentucky site is where we'll focus on. So this used to be back in the 50s and 60s, a US steel factory, and they used to bring in metallurgical bituminous coal. And the fines that were too small for their actual production process, they just used to throw into the adjacent lakes. And over the years, as you can imagine, that's formed large sumps of coal seams. That's an environmental liability, and it's just left there. But it's very good grade bituminous coal. So the purpose really is to utilize this to remove the environmental liability and use our in-house process to make these into viable product streams as well. So what is the actual Arq carbon? So it's microfine carbon, which is highly calorific, 99% pure, with mineral contents of 1% and less. Now, it can be prepared in bulk, which is the attractivity, and we typically produce this in a flotation and milling process where the mechanical presses are used to actually give a pre-feedstock of 45-55% moisture, which is touch dry. So the best example I can give is a consistency of a brownie. So high in moisture, but you can really touch and hold. This is then further dried to get your, less than 2% moisture. Sulfur levels are quite consistent because it comes from the same coal stream, and you're really looking to manufacture a particle size of D80 of less than 5 microns. So this is one of the first, really, utilizing coal particles of that size with very high purity. So that's really our target to go into different product streams and market streams. So it's very highly calorific. So if you're looking to utilize this in, for example, marine fuel, where you're looking at combustion properties and benefits, this is really an attractive feature, which I'll touch on. And I say it's got a low BET surface. It's all relative, really. So compared to something like activated carbon, which is an order of magnitude higher, it's low. But then compared to its original coal fines counterpart, it's just much higher. So the image on the right, the SEM, is just an image of the wet cake. So it's typically plate-like in nature. And you see the size distribution as well on the right. So I won't really dwell on this too much, but it's just using existing technology that we've built up plant. So you see some images at the bottom that typically rely on froth flotation as well as milling in a very iterative manner. So the idea really is to really break the coal fines down into much smaller particles, which in turn liberates the ash or the mineral entities, which gets floated and removed through hydrophilic, hydrophobic interactions. So then you're separated after several iterations of milling and floating pure coal of 5 microns and mineral entities, which we are looking at avenues on the agricultural side of things as well. So that's basically our raw material feedstock, which then goes into several different avenues. So the advanced carbon products is really our bread and butter. So the granular activated carbon, which is where we are existing selling in the markets, both on the powdered side and the granular side. We've touched on work in the past on carbon black, looking at tire rubber applications. We're currently working with end customers for asphalt emulsions. So bitumen, I think they call it in the UK, bitumen emulsions, where we are able to partially substitute a portion of the bitumen with our material to stretch the barrel in an existing supply shortage environment. And looking at obviously the battery side. So I'll talk more on the graphite and the battery side of things. We have focused extensively on the marine fuel as well. Again, the same concept of utilizing up to 10% of our Arq powder as a substituent for marine fuel. It combusts very well, and we've done some ship trials as well, proving this out with end customers waiting to take the next step of trials. So switching gears onto the portfolio that we have done and are looking into, we thought, well, let's try and look at the graphite battery sides of things. So we know that the demand for the battery material continues, especially in light of recent introductions of EVs. It's projected to grow at a steady but quite high percentage throughout 2030 and beyond. On average, you're looking at up to 10 kilos of probably even more of graphite per EV. And speaking to relative people in the markets, we know that, for example, the automotive manufacturers, the procurement guys have already talked about the shortage of graphite for EVs, and they're struggling with supply at the moment. There is an inherent shortage of the carbon feedstock as well. So a lot of refineries are shutting down globally, and that's due to old configurations, differences in end customer needs, as well as obviously everyone chasing to get the lighter ends into the market, which is more profitable. Also, the reduction of the coke oven capacity, which is one of the processing units in the refinery, and an element of HSE as well on the pitch side of things. So both synthetic graphite and natural spheroidal graphite are needed for battery anodes in a correct configuration to get the best of the electrical properties. And the natural graphite purification predominantly prevalent in China, and the feedstock as well are confined in China. So this is, for now, a very China-centric market, which we obviously have from a geopolitics standpoint, from availability, price confliction, numerous areas that we'd like to see change as well going forward. So the mechanisms to produce graphite, typically we need to have as pure carbon as possible. So this really relays on our feedstock, which is 99% pure, and we're pushing that to be higher in purity. The Schiessen process heats, obviously, or cooks the carbon at 3,000 degrees for extended periods. It's a consumer of electricity, as we all know, and obviously there's CO2 and sustainability elements that are affiliated with this. But at this temperature, when considering the Arq material for this process, some of the 1% impurities, which are predominantly alumina silicates, volatilize, which allow the grades to grow, the mesophase, and continue in the annealing process to form the desired larger domains. Now, to allow for ideal phase transformation, we need impurities to be 0.05% and below. And the Arq carbon, we believe, is a good precursor with low ash for the volatilization, which brings down the ash values in an order of magnitude lower. So this is obviously very preliminary from our studies, but we wanted to see if this was the way forward. So we have worked with the Western Research Institute and a few other big American universities on looking at three particular paths for introducing our Arq powder into the supply stream. So typically to produce synthetic graphite, you can take this as 4 stages: powder preparation, the molding, shaping side of things, baking, and the graphitization. So if you look, for example, at route A, we could potentially utilize our Arq powder in the pre-feed for the pet coke outcome. So in the actual delayed cocoa of the refineries, we can utilize our Arq powder with the pre-feed, which is the vacuum residue bottoms of the refineries, which we've done work with the Western Research Institute. I think this is a viable approach. You can then take approach B, which is a complete substitution, and use this as a standalone raw material for the blending, shaping, and the step thereafter. Or you can use this as a binder in pathway C with the actual coal tar pitch to act as the actual so-called glue to take the next step to the blending and shaping and so on. So these are the three areas that we're working on, and we've done some preliminary studies on this. We also have done some work on natural graphite wastes that we are able to utilize our flotation methods in our Corbin plant to really purify this from 95% to 98% as well. So again, very early stages, but there may be an opportunity to look into the synthetic graphite and the natural graphite as well. So this was some of the work done several years ago, by several, I think 2020, with Manchester University on the evidence for the synthetic graphite. It's very early stage research, so we haven't cracked the code on the nut at this stage. But if you look on the chart on the left, you see the conductivity of various different Arq samples. So the Arq Fuel 1 and 2 are just the Arq powder as is. I see the conductivity being quite poor. As you start raising the temperature and heating these in the appropriate conditions, at 500 degrees and 1,000 degrees, you start seeing the conductivity go up. Taken to 2,000 degrees, you see it go up to the 10,000 Siemens per meter. It's on par terms with carbon black, but still an order of magnitude below the actual desired 100K Siemens per meter for the graphite. We do see that prolonged higher temperature annealing brings the conductivity to about 15% below what's needed. So there is a way around and this in terms of prolonged annealing and condition alterations. The spectra on the right, the Rumman does some X-ray diffraction as well, shows that the notorious G and 2D Rumman bands, which are characteristic of the graphite, being present for the spheroidal graphite, as well as the Arq powder itself, which in this case was cooked at 3,000 degrees. You see the notorious D band, which is a sign of defects present as well. So what we are trying to do going forward is really improve the electronic properties as well as the degree of graphitization by extended prolonged annealing at 3,000 degrees. But more importantly, looking at our raw material feedstock as well, just to optimize the process to see if we can get that 1% ash lower in our production capacities. What's important to note here is that we typically produce 100,000 metric tons per annum of the Arq powder in our Corbin facilities. So really what we're looking at is whether or not we can take our artifact, graphitize it and scale it up in a technological and economical manner, which is quite difficult to do, especially on large scale. Going forward, we see ourselves as a bulk supplier with very low ash, pure material with low carbon footprint. It's worthwhile to note that our feedstock is not mined. So it's already waste that's left over the years. So when you actually do sustainability and life cycle analysis compared to your typical feedstock comparator in terms of pet coke in the refinery, you have lower carbon credit based on the overall cradle-to-grave life cycle analysis. Now we're looking for a partner to really drive the next steps of development, and by this I mean really looking to optimize the graphitization technique. We appreciate that adhesion process is very expensive. There may be alternatives, early stage research, or people doing development in the world of microwave technologies and others. Once obviously we optimize our electronic properties and the pure quality of graphite needed, then it's about looking at battery testings and really finalizing the manufacturing and scale up side of things. So yeah, in a nutshell, I'll accelerate it because I appreciate everyone wants to have their coffee break, but we are a supplier of high quality coal at microfine particle sizes, and we will work at Manchester University and looking for potential partners who have close engagement with lead adopters to take the next step of development. And with that, I'll close the talk, and happy to take any question now or later in coffee break. Thanks very much.
Any questions for Rumman, please?